So we were actually trying to figure out this reaction, that the enthalpy change of formation of a hydrated calcium ion is the enthalpy change of the following reaction. This was the question that
Yeah.
you had to somehow figure out the enthalpy change of this particular reaction. So I had copied that, right,
Mm-hmm.
over here, and I was given. I mean, I need to figure out the enthalpy change of this reaction. This thing over here. This is the unknown, and that's my path. That's the path I want to figure out. And what I'm going to try and do is I'm going to create this other path, and I'm going to see if I know the enthalpy change of this other path. As long as I'm reaching the same point, the enthalpy change would be exactly the same. The energy changes would be exactly the same. So in the question that we were doing, there were two reactions whose enthalpy change were already mentioned. One was that they had given us the energy change that would be the change that would happen if calcium solid changes into calcium gas. So last time what we did was that we know the energy change for changing calcium solid to calcium gas. So that is what we did. Calcium solid was changed into calcium. Was was changed into calcium gas. Is this clear, Amal?
Yeah.
Okay, so the only thing that's happening in this path over here is that you're changing calcium solid to calcium gas. The rest of the things remain exactly the same. And the energy change for this particular path is 177, right?
Yeah.
So this is 177 kilojoules. Then you were given another reaction, that the second reaction in which calcium 2 plus aqueous was getting formed, and it was getting formed from calcium 2 plus gaseous ions. So you had calcium 2 plus aqueous over here, and in the equation, it was getting formed from calcium 2 plus gas plus aqueous, right? Like if you have a look again,
Yeah.
calcium 2 plus aqueous was getting formed from calcium 2 plus gas plus aqueous. So the enthalpy change for this particular path was also given, and that was given as minus 15. It was given over here as minus 1565, right? So this value was also known.
Yeah.
And what was this part? The path that is still missing in between. What was this equal to?
Um,
Like what's happening in this green path? What's the reaction that's taking place over here?
is um it was an ionizing entalpy, right?
Like, what's happening?
It's an entalpy change, right? Where it gains the two plus it loses two electrons.
So it basically loses two electrons, right?
Yeah.
And I mean that's the only thing that's happening. I mean the aqueous part is not doing anything. Uh, I mean the aqueous, nothing is happening to it. It only loses two electrons, and that's the first and the second ionization energy of calcium. So you can have a look at the first and the second ionization energies which are given over here for calcium. Uh, I mean somewhere over here. This one 590 and 1150. So that was the
Yeah.
value. That was the value that was missing. It was 590 and 1150. I mean, it had to lose two electrons, right? So what was the
Yeah.
Hess law? Hess law was that if you want to figure out this path, and let's call that path number one, then the enthalpy change
Yeah.
of this other path is going to be exactly the same. Both paths are going to be equal. So, okay, so your enthalpy change for the reaction that you were trying to figure out would be equal to this other path, which is going to be 177 plus
Yeah.
it's going to be 590 plus 1150 and minus 1565, right? So
Yeah.
can you try and calculate this?
Is it 352?
Okay, so it's going to be 352, and that's probably an answer over here, which is 352. Okay, so let's try and do this question now. Now, if you look at this question, then you're being asked to find the enthalpy change of this particular reaction, which is
Yeah.
if I copy this, it's carbon dioxide plus H2, and it forms. So it's carbon dioxide. I mean, this is the enthalpy. This is the path that. I mean, this is the reaction. So it's carbon dioxide gas plus I think H2 gas, and it forms what, carbon monoxide plus
Yeah.
H2O, I think. Let me just have a look. I mean, this is what, yeah, all of them are gases, right?
Yeah.
So all of them are gases. So I want to start at this point and I want to end at this point, right?
Yeah.
And the middle, I mean, that's the enthalpy change, that's the energy change that I'm looking for, right? I want to figure out what this value is. Um, but I'm going to try and find out this other path. If I'm able to figure that out, the enthalpy change would be exactly the same as this other path. So starting with, let's start with anyone like carbon monoxide changing into carbon dioxide. What is it required? Minus 283 kilojoules, right? Changing carbon monoxide to carbon dioxide. So I'm going to go back and see that I have carbon monoxide over here, right?
Yeah.
So why don't I change it into carbon dioxide and keep the H2O as it is? Like both of them are.
Yeah.
So both of them are gaseous, right? So what I only did was I changed carbon monoxide to carbon dioxide, right? I mean, you had carbon monoxide, I changed it into carbon dioxide. I mean, that was the first part, right? Carbon monoxide changing into carbon dioxide, and the value is minus 283. So the enthalpy change for this reaction is minus 283. Amal, is this clear?
Yeah.
So what else? So I've connected the first equation. What about the next one? It's H2 getting converted into H2O liquid, right? So you have H2 over here,
Yeah.
and it gets converted into H2O liquid. So I have H2 over here, and I'm going to convert that into H2O liquid. I'm going to keep carbon dioxide as it is, not do anything to it. But I'm going to convert the H2 into H2O into H2O liquid. So
Okay.
so the energy that is required for that is where's the so H2 into H2O liquid, right? That's minus 286. Someone, is that clear?
Yeah.
Now tell me what's this last step? And what's happening here?
Um,
Like, have a look at this last. What's going on over here?
there's not. It's um,
I mean,
it's just moving, right?
this one? Is there anything happening to carbon dioxide? Any change happening to carbon dioxide?
No, it's the same.
And what about H2O?
Your H2O stays the same as well.
It changes from liquid to what's the state over
Oh,
here?
okay. Oh yeah.
So
Oh,
that's
gas.
so it changes from liquid to gas. I mean, that's the last part over here. And the value is minus 44. But you're going in the backward direction, right?
Yeah.
So it's going to be plus 44.
Okay.
So this path over here would be plus 44. So, I mean, now if you look at focus on the arrows, right? One path is equal to the other path. I mean, this is your first path. I mean, this is the path that you want to figure out, and this over here is your other path, right? And the two enthalpy changes
Yeah.
would be exactly the same. So there's one arrow which is going in the wrong direction, and that is this one. I mean, you go from carbon dioxide to carbon. I mean, this part. Then from this to you go to this part, and then from here you go to the products, right? So this arrow has to be. I mean, its direction needs to be changed. So it would become plus 283. Is that clear? So we're going to change the we're going to change the direction because we want to go from the reactants to the products. Now try and calculate the value. The enthalpy change of the reaction would be equal to what? Minus 286 plus 44 and plus 283, right?
Yeah.
Is this clear, Amal?
Yeah.
So tell me what the value is.
$41.
Okay, so the value for this one is 41
$41.
kilojoules. Okay, next one. Try doing this question. As the first thing, he's asking you to find the enthalpy change of formation of iodine trichloride, ICl3 solid. What is the reaction is he talking about over here?
So it's the first one, right? So you need to do
Hey, what is enthalpy change of formation?
you form the products.
Which is ICl3 in this case.
Yeah.
And they have to be 1 mole from what? Like enthalpy change of formation is that 1 mole of products, 1 mole of substance has to be formed from its,
Yeah.
from what? I mean, look at the definition of enthalpy change of formation.
Um. That's when is it use combustion almost. Like the 1 mole of a compound
Is
is
formed.
formed from its elements
Yeah. So what are the elements here? You have iodine,
and chlorine.
and they have to be in the standard state. So it's the diatomic, right? So it's going to be half I2
Yeah.
and 3 by 2 Cl2, right?
Mhm.
So this is the part that you have to. I mean, this would be solid, and this would be gas. So this is the enthalpy change that you have to figure out,
Yeah.
right? You're going from the reactants to the, as you're going from the reactants to the products.
Yeah.
Now try and figure out this other path. Can you think for 5 10 minutes and work on this? Like two reactions are given. You're given two reactions. You have to create this other path. This is the enthalpy change that he's looking for. Do you get the question?
Yeah.
ठीक है चलो try and solve this. Try and draw the hair cycle on your own.
So you write out the other equation.
I mean, there's one equation over here where I2 gets converted into. I mean, there's I2 getting converted into I2 solid getting converted into I2 gas, right?
Yeah.
So convert I2 solid to I2 gas. Keep the Cl2 as it is. I mean, is
Yeah.
this clear?
Yeah, I did that.
Okay, so that's plus 38, right? And
Mhm.
then you're just left with one path, which is this one. What is this path? Isn't it this path?
Yeah.
That I2 gas and 3Cl2 gas are getting converted into 2ICl3 solid. So this is minus 214, right?
Yeah.
So what's the enthalpy change now? One path should be equal to the other path. So this is one path, and that's your other path. So your delta H would be equal to plus 38 and minus 214, right? Is that clear?
Yeah. Also, minus 172.
So you're getting what? Minus 176.
76.
So that's the value that you're getting. But remember, initially you doubled the number of quantities. You multiplied the whole equation by 2, right?
Yeah.
So that means this enthalpy change is double the enthalpy change that you're looking for. So what you do is you divide this by 2.
Oh, okay.
Okay, because you had increased the quantity of the reactants and the products. You multiplied everything by 2.
Okay.
So
So
the
it's
answer,
minus 88 then?
okay, so the answer is minus 88. Okay, then try doing this question now. It's a similar question. You're being asked to find out the enthalpy change of the formation for solid iodine trichloride, right? Again, but this time
Okay.
the reactions that are given to you, they're different. So try and draw the Hess cycle.
Okay.
You can try and do this one as well. See, let's try and find this out. It's the same equation, right? It's the elements getting together to form ICl3 solid, right?
Yeah.
And it should the elements. This one would be a gas. This one is probably a solid. Iodine is a solid under standard conditions, right? And I'm going to double it so that
Yeah.
I don't get fractions. Like there would be I2 and 3Cl2, right? So this is the enthalpy change that I need to figure out. So what? How can I connect the reactions together? One thing is, if you look over here, ICl3 solid is getting formed. So ICl3 solid is getting formed.
Yeah.
What I can do is I can double that. ICl3 solid is getting formed from ICl solid.
Okay.
I'm going to double it and 2Cl2 gas, right?
Yeah.
So this is what's happening. Uh, ठीक है, that's and the value for that is going to be minus 88 times 2, right?
Yeah.
It's going to be double because I'm making 2 ICl3. ठीक है, Amal, is this part clear?
Yeah.
I said now the other part is that the I2 and Cl2 are reacting together to form ICl solid. So I think it's this path. This one is this one is 14. Reason I say that's the path because I2 and Cl2 reacting to form two ICl solid, right? So I2 and Cl2, if I2 and one Cl2 react, how many Cl2s would be left? Two of them, right?
Yeah.
So do you get this part that this path over here is plus 14? Is that clear?
Mhm.
So tell me what is the value for enthalpy change?
Um. Minus 162.
But I doubled everything, so it should be divided by 2. And
Oh
that
yeah,
is,
divide it. I forgot to divide it by 2. So it's minus 81.
it's going to be minus 81, yeah. So this one is minus 81, and now, as I remember, most of the time you don't actually have to draw the Hess cycle. I mean, we're going to study formulas probably in the next class, uh, which would make it very easy to actually solve these questions. You don't actually have to draw Hess cycles. There are very few questions that actually
Okay.
require you to draw Hess cycles. So, uh, where's the paper? Now we're going to do another one, probably this one. And over here, he's saying that the enthalpy change. I mean, this is cyclopropane. He's saying that the enthalpy change of formation of cyclopropane is 53.3. Do you know what cyclopropane is?
Yeah, I think so.
I mean, it's this thing. It's C3H6. I mean,
Okay.
it's this thing. It's three carbon atoms connected in a cyclic manner. Each one would have two hydrogens, right? So
Yeah.
C3H6 is going to be formed from its elements. So the elements are three carbons solid plus three H2 gas, right?
Mhm.
This is I don't know what the state is, but and the value is given that the value is given as 53.3. Okay, is this clear?
Yeah.
I said now he's asking, he's saying that the enthalpy change of atomization of graphite is 717. What he means is that the carbon over here can be atomized to three carbon which are gaseous, right? And the H2 gas molecules remain exactly the same. Is this
Yeah.
clear?
Yeah.
So, so in this path over here, the only thing that's changing is the carbon solid getting converted into carbon gas, right? And the value is given as 717, and you're going to multiply it by 3 because you're doing it for 3 carbons. So is this clear?
Yeah.
Enthalpy change of atomization is for one carbon. Enthalpy change of atomization is when a solid element or whatever element in its standard state turns into gas. So now,
Okay.
I mean, this part is this clear? Is this fine?
Mhm.
So now after that, he's saying that the bond energy of HH is 436. So you break the HH bonds. So keep the carbon gaseous and you break the HH bonds. If you break them, you're going to get 6 hydrogen atoms, right? So how many HH bonds did you break? You broke 3 of them. 436 into 3. Is this clear?
Yeah.
And then he says that the CH is 410. Now to make cyclopropane, you would have to make how many CH bonds? That's of them over here, 2 of them over here, and 2 of them. So you need to make 6 C and H bonds, right?
Yeah.
And this part is going to be exothermic. And not only that, you would also have to make these C and C bonds, 3 of them. Okay, so Amal, I'm going to repeat this. He started off by giving us the enthalpy change of formation of C3H6 from its
Yeah.
elements, and we got 53.3. That was given over here. And then he's talking about the enthalpy of atomization of graphite, which is that carbon solid changing into carbon gas. And that we figured out would be 717 into 3 because you have 3 carbons. Then the HH bond was broken, so 436 into 3. You got this. And
Yeah.
then the atoms got together to form this molecule over here, which is this one. So they ended up forming 6 C and H bonds and 3 C and C bonds. And the reason a negative sign is put over here is that it's bond forming that's happening on the other side. I mean, this side.
Yeah.
Okay. Is this example clear? And
Yeah.
and can you figure out the CC bond energy? That is the only thing that is unknown. All the rest are completely known.
Okay. Plus- Is it 313?
We don't have 313 actually. What did you do? One path should be created. I mean, this one path is going to be equal to the other path, right?
Yeah.
So it's 53.3, and that's equal to 717 into 3 plus 436 into times 3, and then minus 6 C and H bonds. That's given over here, 410. And then it's minus 3 C and C bonds, which are unknown. So you have to make C and C bonds the subject of the equation.
I know that's what I did. I don't know why my calculator is doing that. Let me try again. 177.
The answer is 315 actually.
Yeah, I said that.
You're getting 313, right? I mean, check where
I
the.
said 315.
You said 315. I thought
Yeah.
I thought it was 313. No, ठीक है, that's fine.
Oh.
It's going to be B. So ठीक है, Amal, but you get the idea, right? I mean, solving Hess cycle questions is going to be very difficult because you have to
Yeah.
somehow link all of them up and make a cycle. The good thing is you don't get a lot of questions on Hess cycle. Most of the Hess cycle questions, there's a shortcut. So next class we're going to learn
Okay.
how to. I mean, the shortcut is really easy. It's like you're going to solve the question in within a few seconds. But the bad thing about the shortcut is that you can't always apply it. So this is your fallback. This is
Okay.
so the formulas only apply under certain conditions. So we're going to do that and discuss that in the next class then, okay?
Okay, that's fine.
Okay then. Take care, man. Allah Hafiz.
Bye.